Hi, my name is Caleb McGrady, and this is my sports scheduling honors petition presentation to fulfill the requirements of the Liberty University Honors Program. I am petitioning NGI 350, and I will be using constraint programming to recreate the season schedule for Liberty University's 4v4 Intramural flag football spring season in 2019. And I will use standard scheduling constraints as well as specific constraints that pertain to this intramural league. This problem involves finding a schedule for the sports league, and the league has 12 teams that play games over a season of 7 weeks, and each team will play some teams twice, but not all of them. There will be 84 total games throughout the season, and games are played on Tuesdays and Thursdays of each week during the season. Each of the 14 days in the season when games are played has 6 time slots in which games can be assigned, and each team plays twice a week with one on each day that games are played. And for each pair of teams, they are opponents no more than twice in a season, and if they play twice, they cannot be successive weeks. And the goal of this project is to create a feasible schedule with these constraints. So here in IBM PLC Plex, you can see that I've specified I'm going to be using CP, which is constraint programming, and then I list my problem description, and then I list an integer for the number of teams in the league, a range for these teams, an integer for the number of weeks that are played, a range for these number of weeks, and then a string that is named league, which contains the teams that are in the league. And then if I go over to my dat file, you can see that I have specified these values, and here are the 12 teams that are in the league. Some creative names for intramural sports, as you can see. And so then back over in the mod file, you can see that I have a decision variable interval or integer that is called game, and it is dependent on the teams and weeks variable, the ranges, and it is in the teams range. And so you can see that this scheduling is subject to, for all the teams and all the weeks, a team cannot play itself. So a game between one team and a week cannot equal a game between that same team, because then it would be playing itself, and that's not allowed. And then also they must be symmetrical. So a game of a team and week, if that team is playing in that week, it must also be the same value for a game of the other team and week, where the T must be equal to make it where one team plays another team, and it's reflected on each team schedule. And so then each week each team is assigned to one game. So for all the weeks, all the T in teams in the game variable must be all different, because a team cannot play twice in a day. And then the non-successive weeks constraint. So for all the weeks and T in teams, if the game is played in week 1, say, then it cannot be played in the next week. And so that works for every week of the schedule. And then, so some of these constraints, I was working off of an OPL example, which was about sports scheduling, and I was using that to model my code off of, but I needed to change it to fit how I needed to schedule this league, because that league or that example was just each team play each team once, and so that wouldn't work, because I have to allow for teams to play twice for 3 weeks, because there's more weeks than there are teams. And so I needed to create these 2 constraints on my own to be able to get the program to work and model the right season schedule. And so for this, games between the opponents can only be played at most twice in the season. So for all the T1 and T2 and teams, the correct number of games would be the count of all the weeks where a game between T1 and T2, and that must be less than or equal to 2. And then this one's kind of similar to the previous constraint, where they must play at least once. And so again, it's for all the Team 1 and Team 2. And then the count of all the weeks where these teams play must be greater than or equal to 1. So this basically means that they'll either play once or twice, but they cannot play any less or any more than that. And so then I executed this debug statement where it will print out a dashed line, and then it will print out the week and then the week number, and then another dash line, and then below that it will print out the team name, and then that team will meet and then the other team name that it will be playing. It'll print that out for each game. And so after I've ran the solution, here you can see what the printout would look like. And so for week 1, these would be all of the games with the team name playing their opponent. And then that will be for each week in the season, which will pertain to the game days. And then with the output, it will also output this matrix with the team number on the side, 1 through 12. And then these correspond to the team names in the array for the string array, and they're corresponding. And then the columns are the weeks, and so they go from week 1 to week 14. And then, as you can see, team 1 will play team 7, and then down here, team 7 will play team 1. So it is symmetrical. You can see that it would work for any of these examples. Whichever team corresponding here will be the same down here. And then if you would count it, there is a max of 2 times a team will play a team in the season, and so no more than 2 times, and also they will play every single team. So through this project, there were several lessons that I learned. The main one I learned was to utilize the scheduling tools in OPL, and some of these include the decision variable array, and then also the symmetrical constraints for game scheduling, which was new. And then I also utilized the all different constraint and the count function in the constraints. And then I just gained valuable knowledge on how constraint programming works through this project. So to conclude, I used constraint programming to schedule a sports league, and it's very complicated to do. It took me quite a while to get this program to actually work, and I had several issues with it but it finally worked. There are many constraints that limit the feasible solution space, and I was able to find a feasible solution for the proposed intramural league with the constraints that I set that are required of the league, namely the being able to play every team once and a few teams twice.